Well, good morning, everyone. This is Paul Bergland, and we are going to start our program now. Program today is called Managing Energy for Organizational Gain, an introduction for implementers. Just a little housekeeping at first. I have everybody muted so that we do not get disturbances from the background. If you do have a question at any time, please send it to me in the chat window, and I will answer that question depending upon how much time we have at the end of the program. Also, the um, webinar is being recorded, so I'll make that recording available to you sometime in the next couple of days after it's all processed and set up for access. Let me talk a little bit about why I titled this program what it is, Managing Energy for Organizational Gain. I think the realization to me is that managing energy is something that touches every facet of your organization, that energy reaches out and every individual, every department, every process in your organization uses energy. And therefore, if you're discussing energy on an organizational level, you necessarily include everyone in that. It's possible then to take this conversation and make it into an overall gain for the organization. That is, to get non energy benefits, to streamline the organization, to transform it into a more productive organization. The process in doing that is very straightforward, but it's not something that can be looked at directly. I like to think of this as the way it is when you look at a faint star in the sky, that you can see it out of the corner of your eye, but if you look directly at it, you can't see it any longer. And I think it's that way with organizational transformation, that as long as we look at energy, we can see the transformation we're making on the organization. But if you decide to focus on organizational transformation, then it's much more difficult to do. In any event, why don't we get started today? I want to talk a little bit about our energy picture because it's radically different than it's been in the last few years. We will probably never see the energy scene that we've had for the last 25 years come back to us. And there are a number of reasons for that. The first one is I believe that we are reaching a state of peak oil. Now, oil is not running out. We are not running out of oil. We are, however, running out of cheap oil. The oil industry themselves are seeking ever more expensive sources of energy and sources of oil. When you look at the tar sands in Canada, when you look at the deep sea drilling going on in the United States and around the world, when you look at biofuels, when you look at fracking, all these processes are tremendously expensive to start and very expensive to continue operating. The only thing that would justify that expense is if you believe the cost of oil will continually go up. And that is what I believe the energy companies see happening. A second facet that's changing our energy picture is carbon caps. They're happening in one form or another all around the world. Australia now has a carbon cap system. Europe does. The state of California does. British Columbia in Canada has a carbon tax. The Northeast United States has a carbon cap system for its power plants. So this is something that's happening, and we should be very grateful that it is. In the long term, this definitely saves us money and perhaps even saves us a planet. In the near term, however, this makes fuel more expensive, which is all the more reason that people should be attentive, organizations should be attentive to their energy consumption. A third facet that's changing our energy picture is global unrest. We've seen global unrest in several parts of the world. It is not a coincidence that global unrest occurs in places where there are oil deposits. The mechanisms of money and corruption are very clear. We should probably continue seeing global unrest in those parts of the world, and since it's a global market for energy, they will affect everybody's prices regardless of where your energy actually comes from. And finally, we take a look at obsolete infrastructure. The infrastructure we have in place especially for our electrical grid, but also our pipeline systems, is nearly 100 years old. This infrastructure is not well suited to energizing a 21st century economy. It's stupid. It is dilapidated. It is susceptible to failure repeatedly from overuse and from severe weather events. The cost to upgrade and or replace that infrastructure is going to come down to ratepayers, and you will see it in your energy bills. So I believe that these four things are the primary reasons that we should be paying attention to our energy consumption. Energy consumption, energy cost will remain volatile from here on out, and we should prepare for that. But it's not all bad news. Lloyd's of London in 2010 put out a report called Sustainable Energy Security. And one of the quotes from that report I really like a lot, so I'm going to read that to you. It says, businesses which prepare for and take advantage of the new energy reality will prosper. Failure to do so could be catastrophic. Now you have to realize that Lloyd's of London lives and dies by understanding risk. And for the most part, they've lived for the last 200 years. And what this means is that when they say something like this, you have to take them seriously. They know what they're talking about. But I also really like this wording. The reason I like this wording is because when they say prepare for and take advantage of the new energy reality, that says to me we're managing energy for organizational gain. We're using our energy situation to develop a competitive advantage over the global market. So there's a real opportunity here as much as there is a hazard. Let's take a look at how to do that. Any energy management system has three fundamental goals. And they are credible energy savings, continuous improvement of the energy management system itself, and persistence. Credible energy savings are key to gaining the confidence of your CEO and your CFO and everybody in the organization. The credibility of your energy savings should not be called into question. And an energy management system is one way to make sure that it is credible. Your energy management system itself should be continuously improved. And we'll talk a little bit about what that means later. But fundamentally, you should continually reach out to encompass more departments, more processes, more employee engagement. And finally, persistence. A strategic energy management system is not something that belongs to an individual. The hazard we run into right now is that there's an individual in an organization who is very interested in energy and they do tremendous work. But when they leave or retire, the energy initiative collapses. An energy management system is designed so that it persists. It persists beyond employees, it persists beyond management, it even persists beyond ownership. It is an asset that continues giving to the organization out into the future. So those are the three fundamental goals of any energy management system. Let's take a quick look at how we'd put that together. A strategic energy management system is designed around the plan, do, check, act, continuous improvement cycle. Some of you may know this cycle was articulated by William Deming back in the 1930s at Bell Labs. Consequent to that, after World War II, he ended up in Japan, where he helped the Japanese manufacturers, particularly the auto manufacturers, to improve their quality with a continuous improvement cycle. After the Japanese automakers ate our lunch in the 70s and 80s, he came back to the United States and found a welcome audience in our own auto manufacturers. And since then, the Plan, Do, Check, Act continuous improvement cycle has been applied to a number of different fields. The on-ramp to your improvement cycle is an energy policy and energy goals direct from top management. The reason for this is that without top management commitment, public commitment, the organization itself is not aware that this is a consideration. People do not feel that they are authorized to expend resources and time on the energy program. Therefore, having the buy-in, having the public commitment of management is the fundamental keystone to having a Plan, Do, Check, Act continuous improvement cycle actually produce results. It needs to be there. In the plan stage of our energy management system, what we do is a lot of the technical work. At this point, you're gathering your information about your energy sources and, more critically, your energy uses. Where is the energy getting used inside your organization? You develop an energy profile document that allows you to have a touchstone for going forward. You develop an energy baseline model. You develop energy performance indicators that will give you normalized assessments of your progress through the years. And finally, you develop energy targets and action plans so that you can actually develop the projects, develop the processes that will yield the energy savings you're seeking. The do stage of the continuous improvement cycle means that we push out our energy management system to the entire organization. At this point, it is no longer just a technical process. The entire organization has to be engaged. People who are working on equipment, people who use equipment that use a large amount of energy, need specific training on the efficient operation of that equipment. People doing maintenance should have specific training on how to maintain the equipment in an energy efficient manner. Everyone in the organization should have awareness training. And I'll bring up this point. The awareness training is the source of all those things that management loves about an energy management system. What that is that they bring the non-capital energy savings projects. These are the projects that involve a change of process, change of behavior. It does not cost any capital, but I've seen tremendous savings for organizations by doing that. So it's very critical that we push this out to the entire organization. In the check phase of our continuous improvement cycle, we do a lot of technical monitoring. Obviously, any projects we put in, we make sure they're achieving the results we anticipated. We do a compliance evaluation, internal audits, corrective and preventive actions. But even beyond that, we should be checking to make sure that our employees are engaged, to make sure that our design and procurement processes have been reformed to reflect energy considerations. We should be sure that we have operational controls on all of our significant energy uses. So we're not just checking the meters, we're not just checking gauges, we're checking the operation of the entire energy management system. That's where our results come from. And finally, in the act phase of our continuous improvement cycle, we do a management review. It's critical to keep management engaged throughout this process and on a regular basis. Management is your sponsor. Management is your authority. Management is where you will get your resources in order to get the job done. A management review gives management an opportunity to reallocate resources, restate goals, and otherwise make changes in direction of your energy management system. It's also critical to their continual engagement in the process. All right, I want to take a look at this same process now, but from more of a functional block diagram perspective. So let me go into a little bit of detail, and this is the part that the managers and executives don't get. This is for implementers who really need to understand how this comes together. What you see here is a block diagram of how we would put together a strategic energy management system for organizational gain. And you'll see that it starts on the top with an energy policy. As I already mentioned, energy policy is critical to making sure that this is a productive system. I want to call your attention to this line right here. Notice the core arrow on our chart drives from energy policy down to action plans and projects. In other words, what this system is about is taking management directive at the topmost level and driving that down in a logical fashion to projects where the rubber meets the road, where things actually get done. In raw terms, that's what this is all about. So the energy policy, as we mentioned, is critical to making this happen. It's the starting point, it's your authority, it's your resource. Once an energy policy has been put in place, you can immediately start your energy awareness and communications program. This is an opportunity to bring the HR department in. This is an opportunity to bring your other departments in, the people who are engaged in the maintenance and operations of the equipment. Make certain that everybody is aware that energy is now a consideration of the organization's activity and that they need to be involved and engaged. It's a good time to bring this out and make sure people are aware and can start submitting suggestions in a two-way communication system. On the technical side, we'll take that energy policy and we'll use that as an opportunity to start our energy review. And as I mentioned earlier, the energy review is the development of an energy profile so that you understand your energy picture. You know where your energy is being consumed, you know where it was coming from, and more importantly, you understand the variables that are driving your energy consumption. That energy review allows you to develop an energy baseline. The energy baseline is critical because it will be the foundation from which you will determine your energy savings. Your energy baseline needs to be technically disciplined and credible. Otherwise, your energy savings will be suspect. Your energy baseline will allow you to come up with an energy intensity. An energy intensity is a good piece of information for management. It's generally considered to be the amount of energy per unit of production or per unit of activity. For example, in a hotel, that may be for per unit of occupancy. Your energy intensity gives management a sense that they have insight into the operation. This is more than just a number. This is something that management can take forward and use as a projection into the future. This is where you show the critical value of an energy management system to management. They start understanding the value of actually managing energy because it allows them to have more control over the organization's activities. So use that. Keeping on top of your energy baseline and energy intensity requires that there will be energy record keeping and updates. As your bills come in, that needs to be updated. As changes happen to your equipment or your operations, those need to be updated. So all of those record keeping and update activities will need to be formalized. Okay, back to our main path. After the energy review, you will identify something called your significant energy uses, your SEUs. These are the items in your organization that you feel are most critical to the success of your energy program. They may be items that use the most energy. Most often that's the case, but they do not need to be. Sometimes the equipment or the processes that use the most energy have no opportunities for improvement, and it makes no sense to list them as a significant energy use if you can't improve them. Sometimes what will happen is people will choose equipment or systems that they feel are most easily improved because it gives them the opportunity to show results immediately to their management. But in any event, you will need to choose SEUs, significant energy uses. These will be the focus of your operations. These will be the focus of your projects. Once the SEUs have been identified, it will be critical that the people who are involved with those SEUs are specifically trained. They should get specific trained on the correct and energy efficient operations and maintenance of that equipment or of those processes. Each SEU will have an energy performance indicator associated with it. This energy performance indicator should be normalized so that from year to year to year, it shows you a measure of your progress, regardless of your activity level, regardless of your production level, regardless of the weather outside. So this will be a normalized performance indicator of your energy program for each SEU. With these values in place, you can put together action plans and projects. You use your people to develop a prioritized list of opportunities and then decide how to approach them. Develop action plans and tackle them. Make those projects happen. Some of those projects are not necessarily equipment upgrades, and I'll show you a few examples in a moment. A lot of projects come from non-capital project ideas that spring from employee engagement. And finally, you'll notice that every single arrow on this chart leads to a management review. Again, management engagement is part of your job. As the energy manager, as the implementer, management engagement is critical to the productivity of your system. Without their authority, without their resources, without their commitment, you're going to be adrift and alone. Make sure to continually get management review On a slightly different configuration here, I want to take a look at the core energy management system elements. And again, you'll see that primary backbone. I call this my fishbone chart. You'll see that backbone. It leads from energy policy to action plans. That's what your energy management system is all about, to take that top level policy, top level direction from management and drive it down. Drive it down to the point where something can be done. Somebody can pick up a screwdriver, somebody can pick up a hammer and make something happen. Each of these items, each of these elements of an energy management system leads to activities below it. And you'll have a copy of this in your charts when I send them to you. I want to talk a little bit now about energy management system results and give you a couple of examples. Here's an example from a company I worked with earlier this year, just a fascinating company. And give you a little idea, they would set a goal by their corporate overlords of a 15% energy cost savings for the year 2013. And so they set about doing this. Fortunately, we started last year developing a strategic energy management system for them. So they were ready when this mandate came down. And you can see on the list there that by April, they had achieved a 16.7% energy cost savings by April. And part of that was because they were smart people. Part of it was because they engaged their people. I want to talk specifically right now about that chiller pump optimization. You see a little asterisk next to that one. It was a non-capital project. Let me talk about what that one is as a little case study here. They ended up getting 5% of their cost saving reduction. I mean, they saved 5% of their energy, their electrical energy spend through that one project. And here's the way it worked. They had a product that needed to be cooled down after it was produced. And the way they cooled it down is they ran it through basically a channel full of chilled water. This chilled water was supplied by 3 pumps that were pushing chilled water down the channel the whole time. Well, the employee who lifted that product out of the bath and put it in the box for shipping noticed that the water was still cold. I mean, you might think that they'd notice something like that for sure. The water is really cold. And his thinking was, well, if we're supposed to be cooling down our product, then why is this water still cold? It should have warmed up. And so they started thinking, well, maybe we have more water than we need. And so what they did is they ran an experiment and they shut down one of the 3 pumps. And they ran their product, a test sample of their product through the bath to see if it cooled down within the specifications. And with 2 pumps running, sure enough, it did. And in fact, they had several products that they ran through, and every one of them met the specifications for chilling. So they immediately shut off 1 pump and decided that one's done. We don't ever need to use that one again. But that begged the next question. Maybe they didn't even need 2 pumps. So they ran the whole experiment over again using all their several different products. And what they found was that every single product made it within cooling specifications on only 1 pump of chilled water. So they reduced their pump load by 2/3. And they're still putting their product out within specifications. And that was all because an employee noticed at the end of the line that, hey, that water is still cold. I wonder if we can do something about that. So that to me is just a great example. This cost them nothing. I think it cost them $12.95 because they bought lockout boxes for the pump switches so that nobody could turn them on again. Cost them essentially nothing, saved 5% of their electrical spend during the year. Now, another interesting thing happened. You see down below, they had process water supply and disposal savings. They had another project that I'm going to talk to you about in a moment, but they actually had 3 projects focused on saving hot water. These were cleanup type projects. They wanted to reduce their natural gas consumption, and I don't have that shown here, but they did save natural gas. The astounding finding from this project was that they went through with these non-capital projects. They saved natural gas, but even more, they saved water supply and disposal savings. Now remember, when you use water, first of all, you're buying the water. Secondly, you're probably pre-treating it before you put it in a disposal system. And then you pay for the disposal. So water is not necessarily as cheap as it initially appears. And what they found in this project is they saved over $250,000 in the first 4 months of this year on water purchase and disposal. This was something that was totally unexpected to them. They hadn't thought this was coming at all. But you can imagine that when corporate saw these results, when corporate saw that these people had reached their target in 4 months, they came running. They said, "What is it that you guys are doing?" A lot of times you'll find that energy savings lead to water savings. There's an energy-water nexus that's a very powerful amplifier. Okay, let me talk about a couple of case studies here. I just want to give you a sense of where these things come from. Actually, I already talked about the chiller pump optimization. Let me talk about a second one here, which is another client I had a large bake oven. This client was making a, how should I put this, a metallic consumable. It was a metal-based product that was actually consumed in the process. They needed, as part of their production, to bake off any volatiles in this product. So they had a huge bake oven. And what they would do is they would, wheel a couple tons of product into this oven, and they'd crank it up to 700, 800 degrees Fahrenheit and let it sit there for a number of hours and just bake while the volatiles came out. This oven was originally a natural gas oven. A number of years ago, they switched it over to electricity. So it's running on electricity now. What they found in this bake oven is that they were baffled by the energy consumption in the bake oven. The reason they were baffled was because they could not understand why the oven energy consumption varied. It varied from day to day to day, and they couldn't figure out why. Well, the logical reason was that the loading, the amount of product that they put into the oven, would change the amount of energy that it consumed. And so the first thing they did is they tried to start recording, how much they were putting in and how much energy the oven consumed. And there was some relationship there. They did in fact find that there was some relationship, but they still could not predict how much energy that oven was going to use. And so they were kind of baffled by this, because that seemed to be the major driver. So they started thinking about it a little more. One of the guys noticed that the energy varied depending upon how much time there was between batches. In other words, the longer the time was between batches, the more energy the second run would take. And what they realized from this, which seems like an obvious fact, but sometimes isn't, what they realized from this is that the energy was being consumed just heating up this massive oven itself. That if they put a batch of product in there and baked it, and then took it out, and then had a 2-hour gap before the next batch went in, that oven would cool off. And therefore, they ended up having to reheat the whole oven for the next batch. So what they ended up doing was just changing their process a little bit. They just made sure that before they started one batch, that they would have a second full batch ready to go right behind it. And so that's what they started doing. And I actually don't think I had their results here. No, I do not. In any event, they saved a considerable amount of energy just because they now sequence their batches. This again cost them nothing. All it cost them was somebody's time to coordinate the delivery of these batches to the bake oven for processing. Another fascinating thing came out of this. And that was they realized that none of them understood how the oven worked. Sitting around in a room, some of them felt that the oven took air from the factory and warmed it up and put it up the vent out the roof. Other people said, no, 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 no. There's a vent coming into the oven, and it's pulling air from outside and heating that up and putting it out the vent. And some people even thought that what the oven was doing was taking air from the factory and venting it back into the factory. So they had a big argument about this around the table until finally everybody just got up and went out to take a look at the oven. Now, this is a fascinating thing because here's a piece of equipment that has been in this facility for over 15 years, and nobody seemed to totally understand how it worked. But because they had to talk about the energy consumption, all of a sudden, They had to know. Well, in the end, what they realize is that this oven takes air from the factory and vents it out the roof. So therefore, it's taking warm air from the factory, heating it up, and venting it out the roof. Now, the problem with this that they found was that as it took the warm air from the factory, there was cold air being sucked into the factory. It was coming in through the doors, it was coming in through windows, coming in through cracks, coming in all over the place. But what was happening is every time they turned the oven on to run a batch, the HVAC was being called into play to heat the cold air that was being sucked into the factory by the oven. They had coupled the operation of the oven with their heating system, which is something they hadn't realized before. So they've done two things. Number one is they put a heat exchanger on the vent. So what happens now is the air being drawn into the HVAC system takes advantage of the heat that's coming up the vent on the roof. So they actually get some of that heat back, which was a good idea. The second thing that they're planning to do, and have not done this yet, is to make sure that the oven has its own intake. They're going to decouple their HVAC from the oven. And they think this will save them energy. It will certainly save them cycle time and maintenance on their HVAC. So this was a finding, and I will tell you one of the most gratifying moments of my career came out of this meeting, where we came out and one of the fellows said to me, he said, Paul, all of this energy stuff that you're bringing to us is great, but the best thing you've done for us is you've made us talk to each other. And that, to me, is the power of an energy management system. That is where the organizational gain comes from. You talk to each other. And if I can facilitate that conversation, that's a powerful thing to get started. Okay, so let me sum up a little bit here. An energy management system yields not just energy savings, there are a number of other benefits that come along with it. One of it seems to be water savings. A lot of times it's an actual reduction in water. Often, and actually I'll say always, you see reductions in your water expenses, either because the water is cleaner going out, so your disposal costs are less, or you're just using less of it. So there are water savings, water and cost. Obviously, if you're using fossil fuels, there are emissions reductions. So if you're under a greenhouse gas regimen of some sort, this is beneficial. I've seen solid waste reductions. The connection is a little tenuous. I think what it is that people who are attentive to energy tend to be more mindful of what they're doing in general. It's another reason to maintain mindfulness, and so people just end up wasting less. And finally, and maybe the most powerful thing to me, is that it breaks down communication stovepipes. Again, energy touches every facet of your organization. And consequently, a discussion on energy includes everyone. People talk to each other from opposite sides of the plant. They didn't know each other existed before. But suddenly they have something in common and they work together. And finally, you'll find those non-capital energy saving projects. A couple of those we just talked about. These to me are the most powerful and of course the most welcome by management. A few things to keep in mind here. These don't come without some work. There's a good deal of work up front that needs to be done technically, good deal of work that needs to be done to develop training programs and things like that. So expect to put some work into this, but I think it's worth it. Keep in mind the goal is a persistent system that keeps on giving, one that remains an asset to the organization long after you're gone. And this is one place people ask me, what does ISO certification do for you? This is one place where ISO certification can help, definitely. If you know the auditor is coming once a year, things get done. That auditor is coming in to check up on you, make sure things are happening. You won't push this off your desk. It gets done. It ensures that it's persistent. There are other ways of getting persistence, and I'm not saying that everybody must go ISO, but an ISO certification can certainly help with that persistence question. Finally, experience is important. Your experience and your team's experience. Okay? You have to own it. It's the wisdom of your people that pays the biggest dividends here. It's the wisdom of your people that shows you the path forward. That's an important and critical part of an energy management system. You have to own it. Okay, and a few thoughts just so you're aware some of the services that we offer. Um, I see our job as clearing away roadblocks. Our job is anything that's in your way, anything that you find difficult, we should be able to help you with and surmount. We will provide full consulting services to develop an energy management system, or if you wish, we'll just develop a model for you, whichever way you want to go. We can also provide training of various sorts for your people on any level you wish. So keep that in mind. Think about where your challenges are. Think about where your roadblocks are, and that's where we can help you. As I like to say, it's not the light bulb we turn off, it's the light bulb we turn on. Okay, and with that, I'll open it up to some questions. If you have any questions, just type them in the chat room there. Okay, and I have one question about how long does it take to implement an energy management system? And that's a good question. A lot of people wonder how long does it take to do this? And unfortunately, there's no fixed answer to that one. I had one client I did this with, and we got it done in 3 months. It was really a phenomenal situation. It was a good team. I walked into the room, and they basically said, "Paul, here's your team. Tell them what to do." So it was every consultant's dream job. And we got it done in 3 months. They got certified in 3 months. Really phenomenal. On the other hand, I worked with another organization, took about 18 months to do it. Not because it was a bad team, but just they had other things thrown at them. They had process changes happening. They had production ramp ups happening, and you all know what that does to your life. So I guess I would tell people it's anywhere from 3 months to 18 months, kind of dependent upon the complexity of your operation and the availability of your people to do this. I have a question here: is how recognized is ISO 50001 certification in the USA among organizations? Yeah, I think it's growing right now. I think everybody felt it got a slow start. It just didn't take off the way everybody thought it would. Part of that was the timing. When it came out in early 2011, people were just kind of recovering from the biggest recession we've had in decades. Um, Organizations had other things on their minds. So I think it was kind of slow to take off, but I definitely see that happening. And the Department of Energy has put out a document now, a case study document showing savings of some large corporations that have adopted ISO 50001. So word's getting around, and it is starting to happen for sure. It's starting to perk. What other operations besides industrial? Yeah, good question. One of the cool things that I see happening is this is moving out into commercial operations. You may have seen the announcement JW Marriott Hotel in Washington, D.C. got their ISO certification just last month. So this is starting to move down, and I can tell you, I can't mention names, but these are names you would recognize if I told you. There are several commercial operations right now. By commercial, I mean they're not producing anything; they're providing services. So these are like office buildings and hotels and warehouses and places like that. Um, they are implementing strategic energy management on some level or another. They're starting to see the value of it, especially those large corporate chains. They are seeing the value of this, even though they're not industrial. So yeah, that's a pretty exciting development happening there. Another thing that we see happening is that it's being pushed down to the supply chain. We're starting to see large corporations recognize that if they are doing energy management, that's great, but that they're still vulnerable to price volatility through their supply chain. And consequently, there's a lot of talk right now about how companies can push this down their supply chain, which is a very interesting dynamic. Let me pick out another question here. Can I do? Yes, absolutely. One of the things that I do, one of the things that we do is something I call a cohort group. A cohort group is where you have 6 to 10 organizations who don't have really big energy use. They're not big industrial operations, but it's enough to worry about. But you get 6 or 10 of them together, and you run them through and develop their energy management systems as a group, and they kind of support each other. There are a couple ways of doing that, and one way is obviously if they're different sites from the same organization, from the same parent organization. So, for example, a hotel chain can pick 6 or 10 specific hotels that they want involved in this, and you run them through it as a group. And it's a very dynamic situation because these people share documents, they share concerns, and I guess the most critical thing, they share war stories, which is just an amazing bonding experience. And so again, you see that organizational gain happen because these people from different sites talk to each other and find out what they have in common. So my answer to you to that question is yes, we definitely do that. We've found a cost-effective way of doing that so that organizations that don't have, the big monster energy consumption can still get savings with a, cost-benefit ratio that works for them. I have another question. What role do consultants play when management does not know where to begin in developing an energy policy? I think, I don't know what other consultants do. I can tell you what we do. And what I do basically when I come in the door, I try to let people grope their way for a little bit because the thought process is really valuable to them. And if they can grope their own way through it, then they're much better off. After they grope a little bit and get lost in the dark, then I'll come in with some suggestions and I'll make some recommendations. I'll say, for example, the ISO says that you should have these things in your policy statement. Or I'll say, I have seen in other places these things in a policy statement, and give them a little something to chew on. But again, my goal is to get them to be thinking about their policy statement. Okay? If push comes to shove and the clock's ticking and these people are clueless, then I will in fact go in and give them a template. But that is like a last ditch resort. As a consultant, it's important to me that I not own this. The organization has to own this. I am just facilitating the development. Okay? I don't know if that answered your question, but that's kind of how I work it anyway. Okay. One last question. What does it cost to do something like this? Well, yeah, cost is another one of those things. It depends upon where you are now. It depends upon the complexity of the organization. It depends upon a whole lot of things. I would say on average, what you're looking at here, not from a cost perspective, but what you're looking at here is something between a half to a full-time FTE from one of your people for a year. If you're not an industrial organization, you're on the low end of that, maybe a third to a half FTE. If you're a large industrial organization with a lot of complex operations, you're probably looking at the high end. Probably going to take an FTE for a year to get all this together. Now, that also depends upon how much you want to farm out. As I said, one of the things we do is we will develop the energy model for you. We'll develop your energy baseline for you. We can develop energy training for you. You still need to be involved in the policy. You need to be involved in the employee engagement. You need to be involved in developing the non-capital projects. Okay, you cannot rule out the involvement of the organization. I can do critical tasks. The consultant can do discrete tasks for you. But at the end of the day, you need to own this. It needs to be yours. Okay, let's see. Yes, thank you. Okay. I do not have any other questions here, so I'll make a final call for questions if anybody would like to leave one. Okay, well, let me thank you all very much for your attention today. As I said, I'll make this recording available to you as soon as I get it processed. I appreciate your interest, and please, if you have any questions, any thoughts, any inquiries, give me a call, send me an email. Our job is to clear away roadblocks. Our job is to make this possible for you. Do not be intimidated. Okay, thank you all very much.